Carbon emissions from fossil fuels are the biggest single cause of global warming, contributing to a staggering 80% of greenhouse gases every year, according to scientists. Coal-powered fuel stations, air travel and the ever-increasing number of cars on the road all play their role. But carbon emissions are having a devastating effect on the climate. It is a problem that needs to be tackled on a global scale if rising temperatures are to be contained. At Nottingham University in the UK, an innovative new centre has been set up to develop new techniques of capturing the greenhouse gases and storing it permanently and safely. The Centre for the Innovation in Carbon Capture and Storage brings together engineers, mathematicians, bioscientists and geologists to create solutions to this pressing problem.
Carbon capture and storage means we take the carbon dioxide emissions that are the main responsible for global warming. We take them out of wherever they're being produced, we isolate them, and then we transport them and store them permanently, so we don't have to worry about them contributing to global warming anymore. What we are pioneering here is the ways by which we are bringing innovation into carbon capture and storage, so there is a wider deployment. The centre is going to allow us now to interface more with industry so we can actually take the science and deploy through engineering. What is unique to the University of Nottingham, and probably I already mentioned, is all the facilities that we have, the brain power that we have, and putting all that together with the mechanisms that the centre will allow us, we believe we can make a difference to basically protect the planet.
PhD students working at the centre under Dr. Morato Vella have been experimenting with new ways of storing carbon dioxide. The most viable and environmentally acceptable form is geological storage, which involves capturing CO2 at source and injecting it into rock layers. Student Susana Garcia has designed her own version of carbon capture technology in a pioneering reactor. In the experiment, silicate-based rocks such as calcium and magnesium are combined with carbon dioxide at high pressures. A chemical reaction causes the rock and the carbon dioxide to bind together permanently. The process is being designed for both below and above ground use. In areas with large supplies of rock, gas can be pumped from source directly underground, where the solidification process takes place. Reactors can also be used above ground, and the resulting solid can be used in the manufacture of building bricks.
We are in both methods, in both processes, above ground and underground, we are always looking at converting the gaseous carbon dioxide into a solid, because in that way there is no way for the carbon dioxide to get released back into the atmosphere. So in the case of the above ground process, it's the same idea. You react a rock with the gas in an aqueous solution, and you are going to get a carbonate, a solid, at the end of the process.
The capture, transport and storage of CO2 presents several challenges. Capture is best applied at source to power stations and industrial plants, where CO2 can be separated from other flue gases. The gas then needs to be cooled and compressed before it can be transported. For larger volumes, pipelines are the only viable option. In terms of the actual storage of CO2, speed and safety are key issues. The reaction between carbon dioxide and silicate rock exists naturally, but takes a long time. The team are working to speed it up for large-scale industrial use. Other methods, such as burial under the sea, often see the CO2 gradually leaking back into the atmosphere. But once the carbon is locked into the rock by the CICCS process, it cannot return to its previous state and is safely contained forever.
We load it up with our rock and an aqueous solution, and then we set up the reactor and we inject the gases we want them to react with. And for a certain period of time we let the reaction go, and at the end we stop it and we analyze all the materials we get out from the reaction, gases, liquids and solids, with different analytical techniques.
After 24 hours in the reactor, the results are analysed using special equipment in the centre's laboratory. The whole process is an expensive one and needs to be made economically viable before being used commercially. The centre is now looking to sign agreements with power and construction companies to work with them and move the system forward. If successful, reactors could be added to fossil fuel plants in the not-so-distant future, treating emissions and converting carbon dioxide to solids at source.
Most of our work has been at the laboratory scale. That's where the centre is going to help us to work with companies and through knowledge transfer as well, process mechanisms, to really test our processes to the next scale, to engage with the companies so they assess the processes that we are proposing and assess their commercial value as well. So we could maybe even start building some pilot plants that will test our processes.
Representatives from international business, academia and government were at the launch of the centre this week, believed to be the first of its kind in the world. Key scientists addressed the audience on the challenges, issues and importance of carbon storage.
Carbon dioxide emissions are a global problem. Once they go into the atmosphere, then they impact the climate. It's been well known, well shown and well recognised now that carbon dioxide affects the climate, causes climate change, and we've all recognised in recent years the more extreme weather events that have been taking place.
Freak storms, violent winds and flash floods are all a warning sign of the effects carbon dioxide emissions are having on the environment. Emissions are trapped in the Earth's atmosphere, creating a greenhouse effect, causing temperatures to rise. It is getting wetter in some places and hotter and drier in others. Extremes of flooding and prolonged drought are set to become more regular unless emissions are reduced. The UK government is taking a lead on carbon capture and storage. It believes these new technologies can help developing countries rise out of poverty while also protecting the planet from further degradation.
It's very important for the sake of Britain and for the sake of the whole planet that we advance in carbon capture, because there's a tremendous amount of coal around the planet. Most developing countries are very dependent on it, but they're as keen as we are not to tremendously pollute the sky and increase global warming. So we're trying to take a global lead in this, develop the technology for our own sake and for other countries as well. It's important for all developing countries to reach a decent standard of living, and we're very anxious not to basically say, no, you've got to stay in an undeveloped state. But if it's done simply by building lots of coal-powered power stations, then in 50 years we're going to have a ruined planet. So what we're trying to do, in partnership with countries like China and India and other countries around the world, is develop technologies so that coal-fired power stations are still good for the planet.
The Daxu biofuel project in China converts agricultural waste into these solid bricks, which are then used to fuel domestic and industrial energy supplies. Creating biofuels like this play a crucial part in reducing carbon emissions. Continued use of renewable energy technologies such as wind and solar power are also vital to securing our future energy supplies.
Unless we do something, we are not going to be reaching targets, and also because we have to do something quick. We cannot wait for another 10 or 20 years, then it will be too late and the cost will be significantly higher. And this is what we are proposing to do here: bring innovation, bring it now and do it quick so we can actually develop technologies and help to mitigate global warming.
Carbon emissions are one of the major causes of climate change, and reducing them is vital if we are to have any hope of sustaining temperatures. The 2006 Stern Review concluded there is overwhelming evidence to suggest that global warming is the most serious and urgent issue of our generation. As the climate gets hotter and wetter, crops will fail, leading to starvation, mass migration and possibly war. The ice caps are melting at an alarming rate, and scientists estimate 50% of species will be extinct in the next few decades. Time is not on our side. Investment from government and industry in green technologies like carbon capture and storage is key to the future protection of our planet. This problem needs a global solution. Without one, the human race faces a future as uncertain as these polar bears as they watch their habitat disappear.